All right, Brandon Clayton here, the Algebra Guy. Today's lesson, writing equations, writing linear equations given in various forms. I'm very excited to be at this point because this is the backbone of algebra, algebra 1 especially, because now we'll be able to take data and draw an equation that we can make conclusions and predictions about for something going on in the future. You'll see what I'm talking about. So this is used in science, this is used in social studies, this is used in math all the time, taking some data and trying to come up with an equation that we could use to make further predictions. So let's jump into it. What are our techniques that we want to discuss today? All right, so the techniques we're looking at is 2B, write linear equations in various forms, including slope-intercept, standard, and point-slope form. Given 1 point in slope and given 2 points. So that's quite a bit there. But we're also going to cover 2C because they're so similar. Write linear equations given two variables, given a table of values, a graph, and variable descriptions. So let's jump into it. Here's the three pieces we'll definitely cover. Finding the equation when you're getting slope and y-intercept. Finding an equation for slope and a point, and given 2 points. All right, so we've easily been able to determine the slope and y-intercept of a line because normally we're given that line in slope-intercept form. So we're normally given y equals mx plus b, and we can easily see what the slope and y-intercept, because whatever numbers are there would tell us the slope and y-intercept. Now I want to work backwards this time in thinking about how we can do that. So I want to give you the slope and the y-intercept. I want to give you 2 points, and a point and a slope, and we can deduce or conclude. I don't know what the perfect word is there, but we're going to come up with this the equation for that. So let's start with this one. Finding the equation of a line with slope -7 and y-intercept 0, -1. So what's the equation? Now I put a graph here. It didn't say graph it, but I want to start out with that graph so you can see the visual as well. So if we want to y equals mx plus b, if we wanted to find the slope and y-intercept, or the equation, we can use slope-intercept form because they gave us the slope and the y-intercept. So that's what I'm going to do. I'm going to say y equals my slope of -7 and my y-intercept of -1. And then we're done. That's really all we have to do there. Now, what if I wanted to graph it? It'd be pretty simple too, right? Because my y-intercept's at -1, so -1 is about right there. It didn't show, but it'd be about right there. And then we'll have a -7, which can be written -7 over 1. So -7 over 1 can also be thought of as 7 over -1 because they're both giving you the same answer. So how am I going to draw that? Well, I'm going to use this one because this one tells me to rise 7 and to the left 1. If I try to go down 7, I could run out of space. Actually, I wouldn't. I can see that. But let's go up 7. So I'm at -1. Going up 7 would bring me to a 6. And then I'm going to go 1 to the left, and there we go. Or I could have gone this way, down 7, which would take me to -8 and over 1, and it'd be right there. So you can easily see that line that we'll end up making like that. So that's pretty good. Bam. So that's just going back to drawing equations, drawing a graph given an equation. Find the equation of the line of this line shown. Now this time I'm giving you a graph. And so I just showed how to write a graph given an equation, but what if I give you a graph? Can you give me the equation? And better yet, can you tell me the different forms of that equation? So we got to get used to going back and forth because slope-intercept form is often the easiest one because they give you the slope and y-intercept. So most of the time, from what I've seen, the STAR test loves to focus on standard form, and they want you to be able to find slope and y-intercept given this, or the equation given this standard form. So let's do that. So in order to have an equation, we need 2 pieces. We need the slope and the y-intercept. So the slope, well, let's start with the y-intercept. Y-intercept's easy, right? Because it's just right here. It's intercepting at a -4. So I know my b is going to be a -4. What's my slope? My slope is going to be identified after finding 2 points. So here's 1 point. And this is a good point because there's 2 integers here. Those integers 0, -4. This is 0, -4. It's supposed to be a 4. Man, that looks ugly. So let's try that again. 0, -4. All right, and this is 3, -2. So 3, -2. So see how these are two nice integers? I can't pick a point in between that because it's going to give me some kind of fraction or a decimal. I don't want to do that. Now I can find the slope by simply asking myself, how much do I have to rise and how much do I have to run? Because slope is rise over run. So I'm rising from -4 up to -2. 1, 2. So I went up 2, that's a +2, and I'm to the right 1, 2, 3. So this is 3. So my slope is 2/3. So now it makes it easy for me to write this equation, 2/3 x minus 4. Y equals 2/3 x minus 4. So I'm done when it comes to the slope intercept. What about the standard form? How would I write that? All right, to get this to standard form, all I need to do is get this x, this x on the left side, so it says something x, something y equals a number. So in order to do that, all I need to do is subtract this 2/3. So subtracting 2/3 x on both sides. Subtracting 2/3 x. Now I'm left with, oh, that's x. Now I'm left with minus 2/3 x plus y equals -4. So I said all I need to do is do that, but I just realized I can't keep it that way because in standard form you can't have this fraction here. We need to have everything in some integer, especially this first letter being a positive. So in order for that to happen, I can multiply everything by this a -3 to get rid of that 3 on the bottom. So I can multiply by -3 and it'll look like this. Let's do this side by -3 and this side by -3. So when I do that, what do I get? -3 times 2/3, but 3 over 3 would cancel out to just 1. So I'm left with just 2x. -3 times my y, I'm distributing here, is 3y. And that's going to equal a -12. I'm sorry, positive 12, right? So positive 12 because -4 and -3. So there it is in standard form. Now look at this. So here it is in slope intercept form. Here it is in standard form. They look quite different. So you can't try to figure out what the slope is from standard form because look, you wouldn't have got 2/3 from just looking at this likely. Now what about point slope form? So this is point slope form. How could I have written this same equation in point slope form? Well, you just need to take a point and the slope. So that's pretty easy. So let's take a point. Let's pick a point. Let's do 3, -2. So let's pick that point. And for our y value, now we know we're going to use -2. So that's going to be minus a -2. Why minus a -2? Because there's already a minus there and this is negative. So don't forget to include that. My slope is going to be, what did we say it was, 2/3. So 2/3. And now I have x minus my x value, which is 3. All right, so when I simplify all this, this becomes y plus 2 and 2/3 x when I distribute this. And 2/3 times -3 becomes a -2 because 3 divided by 3 is 1. And since they're negative, it'll make it a negative. That -1 times 2 is -2. You can just multiply on your calculator if you don't see how I quickly did that. All right, so this is in point slope form. We had it in point slope form here, and I probably could have stopped there, but my temptation is to continue simplifying and multiplying. But this is how it will look if it were in point slope form. And one more step, we get in slope intercept form. So if I would have subtracted 2 on both sides, now I'll be back in slope intercept form. This will give me 2/3 x minus 4. And that's the same thing we saw up here. So they're all connected, but they look different. Know how to go between those. That was going to help you tremendously. Finding the equation of a line given the slope and a point. So we just did that, but here it is formally. So you could use point slope form. Now, side note, you don't have to use point slope form. You could use slope intercept form, and I think I'm going to show you that later on. But I'm going to keep with point slope form for right now. Finding the equation of a line with slope m equals 2/5 that contains a point 10, 3. Write the equation in slope intercept form. So let me think through, first of all, if I had a graph, let me just give you a graph of what they're really saying. They're saying if we had a line somewhere and it was a point 10, let's say 10, 3 is about right here. 10, 3 is right there. There's a point. All right, so then we'll go ahead and label it 10, 3. And we had a slope of 2/5, so we took a slope going up 2 over 5, up 2 over 5, or 2, and you get the point. It's kind of moving in that direction. So what we want to know is, what's the equation of that line we just drew? And this is important because we could put some data to this. We could say somebody after 10 months went 3 miles. I don't know. I'm just making up something. And they were moving at this rate, 2 miles for every 5 months. I can't remember what I said. But anyhow, when you put some context to this, you'll start to see, if I just get one of the points in the slope, I can make a prediction about what's going to happen because of that equation. So anyhow, let's find the equation of that line. How would we do that? Using point slope form would help. Remembering that it's going to be y minus y1 equals m slope x minus x1. I need a point, so for my x and y, so y minus my first point, which is 3, is equal to my slope 2/5 and my x minus 10. What do we want? The equation in slope-intercept form. So we're not done. This is in point slope form, so if you did that, great. Pause it here, see if you can get it in slope-intercept form before I do. All right, I'm coming back. Hopefully you pause it, you try to work it. Actually, I don't want to do that first. I want to make sure I distribute this first. So I'm going to go y minus 3, 2/5. This is going to distribute 2/5 x, 2/5 times -10. Well, that's -10 divided by 5 is -2. -2 times 2 is -4. I'm going to add 3 to both sides now to get this y by itself. And that leaves me with y equals 2/5 x. That's a -1. -1. There we go. So there it is in slope-intercept form. So I know I have a slope of 2/5. I have a y-intercept at -1. So this would have been a -1 where I'm crossing. So that's how you would do it. Pretty simple. Find the equation of a line with slope -1/3 that contains point 6, -4. Again, right in slope-intercept form. Now I got 2 problems here. I want you to work them both before I work these. I'm going to go ahead and jump right into it. Now the table's here because we're going to use that later. And I could have used it now, but I'm probably not going to use it right now. You could put some numbers on here, 6, -4, and apply this slope. You could say, okay, well, I know I have a -1 over 3. So I know this is going down 1 for my y. So down 1 to a -5 and up 3 for my x. So up 3 would give me a 9. So this is went down 1 and up 3. So you could actually start to get some points together like that for graphing purposes, or again finding the equation. But we're not going to use that so much right now. We're going to stick with our point slope form. All right, point slope form says y minus this y value, which is -4, is equal to my slope of -1/3. X minus 6 in this case. Now we want slope-intercept form, so this is y plus 4. Distribute that -1/3 becomes -1/3 x. And 1/3 and -6, this is going to be positive, right? Because I got a negative and a negative. 6 divided by 3 is 2. So I'm almost done. You got to get this y by itself by subtracting 4. And now y is equal to -1/3 x minus 2. So now it's in slope-intercept form. Love it because now it's easy to graph. I can just put -2 on the y-intercept. They didn't ask to do this, but if I wanted to or asked to, I could. And then go down 1 over 3, down 1 over 3, or up 1 to the left 3. That would give me that line for that equation. All right, same thing here. Finding the equation of a horizontal line. That should be easy. That contains -1, 2, right? The equation slope-intercept form. Well, now, why did I put this one there? This changes things a little bit because they didn't give me the slope. Or did they? What is the slope of a horizontal line? Well, horizontal line, so if we had a graph, a horizontal line, here's my graph here, will look like that. Now, how do you remember horizontal? Horizontal sounds like horizon, like you have the horizon, the sun coming up over the horizon. That's a horizontal line. So what's the slope of that line? So you need to remember that slope is going to be 0. So having a 0 slope helps me determine this. Now if I put put this point on the line. Let's say find the equation of the horizontal line contains this point. So it has negative 1, 2, negative 1, 2. Let's say there's a point here, negative 1, 2. So what's the equation of that line? Well, no matter what point, every point on that line has something in common. All the y values are going to have a 2. This is going to be 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, negative 1, 2, negative 3, 2. So the equation of that line is going to be simple. It's going to be y equals 2 because every point on that line has a y value of 2. So that's it. That's all you have to show there. And that seems more simple than you would imagine, but there's nothing else you can do. Find the equation of the line when you got 2 points. All right, so here we go with 2 points. I'm going to use this table here because anytime I'm given 2 points, I always prefer to use a table to find the slope and even to get me started finding the equation. So 5, 4, 3, 6. So it's easy to find. First, I'm going to find my slope. So that's my first thing is I'm going to find my slope. Then I need the y-intercept. Uh-oh, that's not what I want there. I want to do y-intercept. So it's 2 steps here. For an equation, I need slope and I need y-intercept. So my slope will be 2, negative 2. Okay, so that change of y over change of x, or x, or as you're used to hearing it, y2 minus y1 equals x2 minus x1. How much did it change? So I see my y changed 2, a positive 2, and my x went down 2. So what's the slope? If I simplify this, that's just negative 1. All right, good. Now I need the y-intercept. How do I find that? So you could use a couple of things. You can use point slope because we have a point. We have 2 points actually, so pick one and use the slope. Or you could use slope-intercept form. Now, since I want my answer in slope-intercept form, it's easy to graph from slope-intercept form. It's easy to identify the slope-intercept and the slope. I'm just going to use slope-intercept form. So I'm going to write y equals mx plus b. And let's fill in what we have and what we're looking for. So first thing is we are given, not given, but we found our slope is negative 1. Do we have an x and a y? We actually do, right here. And right here. So just pick one of those. So it's kind of like point slope. Just pick a point. Now I'm going to pick 3 and 6. I usually pick the numbers that look more friendly. And for whatever reason, that looks more friendly. My x value there is 3. My y value is 6. Now I still need to find my b. B. Not a 6, but a b. All right, so all I got to do now is solve this for b, and I'm done. I already have the slope, so let's do it. Negative 3 plus b equals 6. I'm going to add 3 to both sides. Doing so gives me b equals 9. Guess what? We're done. We found the slope and we found the y-intercept. Now let's write our equation. So now I know my equation is going to be slope is negative 1. So that's just a negative x plus 9. So this equation will help me find any point on that line. So they gave me 2 points. Now I can find any point. Notice I didn't fill in my x and y because I want the equation for any point on the line. So I'm not going to keep putting those same points in there. So there you go. All right, same thing here. Once you pause it and work this one yourself, see if you can find the equation given these 2 points. All right, so what's the big idea? The big idea is this. If you got these 2 points, what they're asking is if you were to graph them, negative 3 and negative 1, let's say that's right there, and 2, negative 2, 2, negative 2, that's further down, right? So yeah, that's about right there. I can already see that this is going to be negative, so I need a negative slope. So that's kind of cool to estimate that. But what they want to know really is if you drew a line between these, what's the equation of that line? So what's the equation of that line that connects these 2 dots? So here's the way I like to do it. I'm going to go ahead and find the slope and the y-intercept of these 2 points. So first thing is slope. I drew them on the table. I notice it's going down 1. That's my change in y. This is my change in y and my change in x. So it's going, the change is going down 1. And every time it goes down 1, what's happening to the x's? It's going more positive or negative? It was going positive, right? From negative 3 to 2, we went positive, so it's going up 5. So now I know my slope is negative 1/5. Now I need my y-intercept. How am I going to find that? Well, I'm just going to use slope intercept. So y equals mx plus b. I know what my slope is -1/5. I can use one of my points. Let's see, this one has at least one positive in it, so I use that one. So I'm going to use a x of 2, because we're using this point here. We're going to say we're using that point. So there's my x. I still don't know what b is. I'm looking for it, but I know what the y is, -2. So all I'm saying here is that I know my slope and I know one point. Tell me where the y-intercept is. Now you could use this instead of point slope form also, as you can see, because you got one point in the slope. All right, so let's go ahead and do the math here. -2 equals -1/5 times 2 is -2/5 x. I'm sorry, -2/5 plus b. Can't put the x just yet. And let's find b. So to find b, I need to add 2/5 to both sides. 2/5. And that leaves me with, let's change colors here, b equals, what is 2/5 minus 2? Let's see, 2, I have a 2/5 and minus 2. Or rather, let me erase that. Rather, I should say -2. Let's do it that way, because that was already there first. -2 plus 2/5. So this is going to tell us what our y-intercept is. Just punch it in the calculator, but if you know how to add and subtract fractions, let's do it. We need to get the same denominator. Right now, this -2 is understood to have a 1 on the bottom, but they need to have the same denominator. So I'm going to multiply the top and bottom here by 5. So this is going to give me a -10 over 5 and plus 2 over 5. Well, what does that equal? -10 plus 2 is a -8 over 5. So now I know my b is -8/5. That gives me my equation, because now I know the slope and the y-intercept. So the slope is -1/5 x, and my y-intercept is -8/5. There we go. And sometimes it doesn't come out as pretty as you want to, right? And so we don't like those improper fractions, especially negative, improper, but it works out. So again, always check it with your calculator if you're not feeling sure about it. All right, let's do one more like that. -2, 4, -2, -3. So we got -2, 4, -2, -3. Find my y, my slope. This is going down 7, and this is going nowhere. This is not moving. It stays at 2. So this is going to be an interesting one, because change of y over change of x is changing -7, and it's not moving here. So -7 divided by 0 is, what is it? What is it? Undefined. Undefined. No, it's not 0. If you said 0, 0 divided by anything is 0. But trying to divide something by 0 is undefined. You can check it in your calculator, by the way, especially if a graphing calculator. It'll literally say undefined, because you can't do that. So that's going to make an interesting situation when we try to solve this, because now I know, let me see, actually it's easier to visualize this. Watch. So if I graph this and I try to plot these points, so when I'm plotting -2, 4, -2, 4, let's say it's right there, and -2, -3 is right here. So we can see that this is a vertical line and it has an undefined slope. But what is the equation of that line? Yes, there is an equation that we can use. And what is it? So it's going to be a line that goes through like that. What's the equation? Well, what does this line have in common for all the points? So all these points. So let's write this -2, 4. Should be 4, and -2, -3. We can kind of see it because we both got -2. Each time is going to have an x value of -2, -2, -1, -2, 2, -2, 3, -2, 4. It's just going to have -2 for each and every one of those. So I know my x value is always going to be -2. So that's how I can conclude that this is going to be x equals -2. That's my equation. That's all I can put there. And that's all we can do. So let's go to our next problem. Star practice problem. So what did it look like on the star to have these teaks? Let's get to it. Which equation is standard form? Standard form. See, they love to give you standard form. has a graph that passes through point -4, 2 and has a slope of 9/2. So which equation in standard form has a graph that passes through this point? We could easily find the slope-intercept form. I won't say easily, but we can find the slope-intercept form of this and then convert it to standard form. So let's go ahead and do that. So I'm going to say I know what the slope is, and you could use point slope. Yeah, I can go either way. So I'm gonna start with slope intercept, y equals mx plus b, because that's the one most people are familiar with and comfortable with, we use all the time. I have the slope as 9/2, and I have an x value of -4, and a y value of 2. So we don't know our b. So we could simplify this by doing 2 equals 9/2 times -4. Well, I can do 4 divided by 2. -4 divided by 2 is -2. -2 times 9 is -18. And that's plus b. I'm going to get my b by itself by adding 18 on both sides. That leaves me with 20 equals b. So now I know my equation in slope-intercept form is going to be y equals my slope of 9/2 and a y-intercept of b. I'm sorry, of 20. But I need standard form, they said. So let's put in standard form. We're going to subtract 9/2, x on both sides of this, because we need to get x, y, and a number. So when I do that, I end up with negative, let me save some room. So negative 9/2 x plus y equals, so this goes away, and I just have 20. So look, I have it in standard form, or do I? Well, remember, we can't have a negative fraction. We can't have a fraction and it can't be negative. So we want to keep this positive, especially this a value. So to do that, I'm gonna have to multiply everything by a -2. So I'm multiplying everything by -2, this side by -2, and this side by -2. Doing so cancels out this 2. 2/2 is 1. Negative times a negative is a positive, so I get a positive 2. That 2 cancels out, so I get just a 9 actually. Because that ends up being 1. 2 divided by 2 is 1, and 1 times 9 is 9. 9x. -2, and this y would give me a -2y. And -2 times 20 is -40. So let's see if this is good enough. Let's see if I find our answer. 9x minus 2y. 9x minus 2y minus 40. So none of these even have a minus 40, so that makes it easy. So 9x minus 2y minus 40. Now you could have used point slope as well to get right back here, so it's going to be the same thing. And additionally, you could have, and this takes a little bit more time, plugged in every single one of these equations and start to look for which one has these features. But I want to show you how to do it step by step by hand. This takes a little bit more time, but you can get the answer, especially using your calculator. All right, here's another one like that. All right, this time I'm going to do this in point slope form since I did the other one, slope intercept. So point slope form is y minus my minus, because they gave me a point in slope, and y minus a -8, so that slope is 1/4, and then I have x minus my 4. Here we go. So this becomes y plus 8, 1/4 x, because you're distributing here, and 1/4 times -4. Well, 1/4 times 4 is going to give us a 1, and this is going to be a -1 since that's negative. Now we need to get in standard form. Standard form means I need to have it x, a y, and a number. So I need to get my x on that side. I'm going to subtract 1/4 to do that. Subtract 1/4 x to do that. So that gives me -1/4 x plus 8 equals -1. And I'm going to subtract 8. Oh, what happened to my y? I lost my y. I forgot my y right here. Let me go back a little bit. So I subtracted my 1/4 x, but I forgot to say plus y, then plus 8 equals -1. So yeah, I forgot my y. This x, this whole piece just got up here. All right, so now we got to get rid of this 8. So I'm going to subtract 8. And that leaves me 1/4 x plus y equals a -9. All right, so we got it in the right order, but we have a negative and a fraction. So again, we need to multiply both sides by something to get this a positive whole integer here. So in order to do that, I need to multiply this by -4 because negative times a negative is positive, and 4 divided by 4 is going to give me a 1. So now this becomes a x, and when I distribute here, this becomes a -4y, and I got to multiply that -4 over here too. Negative times a negative is a positive, so this gives me a positive 36. So let's see if we have a first. I'm going to start with 36. I don't see 36, no 36, no 36. I wonder where our answer is. X minus 4y equals 36. All right, what's the equation of the line that has a slope of 0? Hi, we've done something like this before, so this should be pretty easy. Actually, I'm not even going to have to work anything out, though you could. I prefer to graph this one. So wow, that's cool. We did 3 different ways of working the same type of problem because of the stimulus that they gave us. So let's say 6, 8. 6, -8 is here. So this is 6, -8, and we have a slope of 0. Slope of 0 means it's a flat line that's horizontal, right? So hopefully you remember that. If you do, that makes this a lot easier. So there it is. So that's my slope of 0. What's the equation of a horizontal line going to be? Well, it's going to have y values that all are -8. So that tells me my answer right there. Y values are all going to be -8. So y is going to equal -8. So I'm really done right there. Now, if you wanted to work it out, you could. You could go y equals, actually, let me back up a little bit. Yeah, y equals mx plus b. You could use that. And you could say my slope is 0. My x is 6. I don't know my y-intercept, but I do know my y value is -8. And then 0 times 6 is 0, and b equals -8. Well, b is just your y-intercept, so y is going to be -8. So that's all you end up with. Same thing we're getting here. So you could have done it that way. To me, it's just easy to see visually what's going on. What's the equation in standard form of the line that passes through this point, 124, and has a slope of 0.6? So same way, I'm going to go back to slope-intercept form. Slope-intercept, I need to put my slope here, 0.6. My x value is going to be 1. I don't know my b, and my y is going to be 24. All right, so my y is going to be 24, and like I said, my slope is 0.6. Now, 0.6 as a slope is not very fun because most of the time in algebra, you want to stick with fractions, and here's the reason why. Because trying to subtract or add 0.4 to this is going to give me 24.6, and it's just not fun. So let's change this to a fraction. 0.6 is the same thing as 6 over 10, because that's in the tens place, which is the same thing as 3/5. So I can say this is -3/5 times 1 plus b equals 24. And now it looks a little bit easier for me to work. So let's see what we can get from here. All right, so now we got to find our y-intercept. We're going to add 3/5 to both sides. And adding 3/5, what's 24 plus 3/5? 24 plus 3/5. Well, I need the same denominator, so I need to multiply this 24 by 5. 24 times 5 gives me 10. That's 12, 120. So this is 120 over 5 plus 3 over 5 is 123 over 5. 123 over 5. So that's my b. Ugh. That's not a fun looking y-intercept, but it looks like that's what it is. So I have what I need. I have my slope. Y equals my slope of -3/5. And I have a funky looking y-intercept of 123 over 5. I need to get this in, oh, that's x there. I need to get this in points standard form. So I'm going to add 3/5 to both sides, or 3/5 x to both sides. This x. And now that leaves me 3/5 x plus y equals 123 over 5. No, you know we can't have this fraction there. So after this point, this is not going to work. We need to get this to a integer, a positive integer. So multiplying by 5 would do the trick. So we're going to multiply all this by 5 and all this by 5. So I need to multiply this by 5. 5 times this is going to cancel out these 5s, and now I'm just left with 3x. Distributing this 5 to the y is going to give me a 5y. And canceling those out will give me a 125, because these will cancel out once you multiply those, or think of it as division. So now I'm left with this as my standard form. 3x plus 5y equals 125. Don't have 125 there, and here it is right there. What if you're given a table? So you can do the same thing. We can take those 2 points and come up with a table. Now I'm going to show you this a little bit differently, because honestly I would not do this by hand, because the numbers are just so big. I don't feel like getting into all of that. And the cool thing is you don't have to. So I'm going to take out my calculator and we'll look at it that way. Alright, so now I have my calculator out. I'm going to show you how you can solve these with the calculator. So in order to solve this, and by the way, you could have done this with 2 points as well, because that's really all I need from this is 2 points, because any 2 points is going to give me a line, because we're dealing with linear functions here. They told us right here it's a linear function. So just take any 2 points. Because I don't want to say, you can call it lazy or you can call it smart, but I'm going to use my calculator and I'm going to pull up a table here. Let me go back and show you what I just pushed. I pulled up this spreadsheet right here, and I'm going to create this table. So I'm going to put X and Y, and all I need is 2 points. So I'm going to put in, you can put in all the points if you want to. I'm going to put in all the points just to make this really easy to see. So make sure you press enter off that last one. Some students forget to do that and they can't read that number. All right, so let's make sure all those numbers are right. All right, from here I'm going to just go back and pull up this one here that says data and statistics. So now I see these points randomly. I'm going to tell the calculator that this is my x-axis, this is my y-axis, and it's going to make, guess what, a line. I need the equation of that line. It'll tell me the equation of the line. Watch this. So we'll go here and press window, analyze this, regression, and I want linear in mx plus b form. So when I press that, it gives me right here. Here's my equation for this line. How exciting is that? So y equals 12x minus 28. See, they say a plus or negative, same thing as minus 28. So that helped me out tremendously. So when I look back here, I at least can identify my slope, and I can figure out what the y-intercept is. Well, it's already given to me. And they gave me in point slope form. So if you would have seen this, you could have actually tried to work this in point slope form, trying to pick one of the 2 points that they're using. But I went ahead and just took the equation. So which one is the right answer? So I know which ones I can at least cancel out at this point. I know for sure my slope is 12, so it can't be 1/12 and it can't be 1/12. Now how can I figure out what it is from here? Let me go back to my, actually I'll leave it here. I'm going to go back to my large screen. So how could I figure out from here? From here, I can remember that point slope form, that is what they're trying to put it in, is y minus y1. So what's my y value that they're trying to use? They're trying to use negative 268. So y minus a negative 268 would be a plus 268. So that's correct. And that negative 20 would be a plus 20 here, because it changes from that negative minus a negative to a plus 20. However, x plus 268 won't make sense because that's not an x value. Y plus 20 doesn't make sense because that's not a 20 is not one of my y values. So I know just from looking at that, that's not going to work. So what did we just do? We found the slope, something that simple. And we could have done this here. Just found the slope between these two, just subtract it and divide it. And just from that, we knew point slope form, how it works. And this has to be a y, this has to be an x, and they were not. So since we eliminated f and g from knowing the slope, and we eliminated j because we knew point slope doesn't set up this way. So now the only answer we have left is h. And you can go ahead and distribute that 12, subtract this 268, and you'll see that it gives you a negative 28. But it's unnecessary. We can just do that by visually inspecting it to see that that's what we're going to get. Let me go back to my screen so that we can see this more fully. All right, so an organization has a monthly budget of so many dollars, X dollars. Every month, $2,070 is spent on salaries. 1/4 of the remaining budget is spent on monthly activities. Which function can be used to find the amount in dollars spent on monthly activities? So I told you we have verbal descriptions also when writing equations. So every month, every single month, 2,070 is spent on salaries. So which one is that going to represent? So we see 2,070 in all of these. So let's read some more to see if we can get any help. 1/4 of the remaining budget. What do they mean remaining budget? That means after they spent this 270, so they've had to take the 2,070 and subtract it from, or the budget, and subtract 2,070. And then whatever was ever left, they divided by 4. So the one that makes most sense is D. They took their budget, subtracted about 2,070, and then what was ever left, this answer right here is what was left, they divided it by 4, which is the same thing as multiplying by 1/4. So this is the one that makes more sense. This one says we're going to take 2,070 and take our budget divided by 4 and add it to 2,070. That's not what they were doing. So this D is the best choice. That's all I say about that one. I think this is our last one. Which equation can be represented by the graph? All right, so the easiest way to work this, be honest with you, is you can just put all these in your calculator. So if you can go to the relation function and put all these in your calculator, or at least put them in standard form, that's probably the easiest way to work it. Matter of fact, I'm going to do that. I'm going to show you how to do that. So if I go back to my calculator, let's clear this. I go to File, New Document, don't want to save it. So if I go to my graph, actually, I want to put these in. No, I'll leave it this way. You could either change these so that it's in standard form, right? So you can subtract 16, like this right here, negative 3x plus 8y is equal to negative 16, because in this case you'll be subtracting 16 on both sides. So now it's in standard form. Or you can leave it this way and use relation. So let me show you both, because this is just a quick lesson on using the calculator. So you could, right now it's in, the calculator is in y equals mode, but we don't have that here unless you want to change all these to slope intercept form, which is y equals. But we could change this so it says, let's go equation templates. Yours may say something a little different, of a line. And we could go to standard form. See, in standard form, it's going to say something x plus y equals a number. So we could change all these to say that, and then put them all in and see which line equals. And I'm looking at doing it this way because it's hard to get some really good points off of here. Here's a good point, and maybe here's a good point, but I don't want to take a chance. So I'm just going to see which line actually looks like this when I graph it. So when I put, so you could use standard form. Or you could go back to graph entry and equation templates, line, and we could use, actually we could use relation. That's what I wanted, relation right here. Instead of equation template, go to relation, and it gives you this blank screen. If you're using a TI inspired graphing, you can just put them in just the way you see them, and that's what I can do here. So I'm going to put all these equation in just the way we see them. So I'm going to start with this first one here, negative 3x. Look like that one because that's obviously below the origin. This one's above the origin. So let's put this last one in. Hopefully it's the right one because it's the only one we got left. Plus 8y minus 16 equals 0. And voila. However you say that word. There it is. So I could just graph that. That's just really the easiest way. You could try to find some points on here, but I just think it'd be you're still taking a guess. So let me see if I wanted to find points. I could find this point here, and here's a point here. So you could find some points. I'm not sure about that point, so I wouldn't take that. I guess this may be a point, but anyhow, I don't like guessing. I don't like how close they are, so I went straight to my calculator. All right, finally, guys, we're finished. I know that was a lot, but this is a big lesson. And this, as you can see, STAR covers it quite a bit. I didn't go through every single problem that you come up on the STAR in the last few years, but a good waft so you can see what type of questions come up when you're tested on writing equations. Great job. We covered, again, our teach looking at it from 2 points, point slope, a graph. We've done it all here. Thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.